Good morning, I'm Dr. Huang. Today, I'm going to teach you a systematic method to write down the Lewis structures with resonance structures and formal charges. There are a lot of molecules and ions whose Lewis structures are very difficult to write down correctly. Here is a list of them. Well, if you can follow the procedures I'm teaching you here, it will be relatively easy and relatively fast to write down the correct Lewis structures with resonance structures and formal charges for any molecule or ion. Well, let me use chloride as an example to illustrate the steps of this method. The first step of this method is to obtain a skeleton structure from an instructor. This is the skeleton structure of chloride. In the skeleton structure, a line, or sometimes a dotted line, between two atoms tells us that there will be a chemical bond between the two atoms. For example, this line tells us that there is a chemical bond between this chlorine atom and this oxygen atom. However, in the skeleton structure, a line or a dotted line is not always a single bond in the Lewis structure. It can also be a double bond or a triple bond. If there's no line between two different atoms, that means there's no bond between the two atoms. The second step of this method is to place the valence electrons next to each atom. Each oxygen atom has 6 valence electrons. Each chlorine atom has 7 valence electrons. You can find the number of valence electrons of any atom from a periodic table. Chloride has -1 charge. Therefore, it has 1 additional electron. Now let me show you how I place the valence electrons next to each atom. You can start from any atom. Let's start from the oxygen atom on the left. From the skeleton structure, this oxygen atom has only one neighbor, which is the central chlorine atom. Therefore, we will take one of the valence electrons of the oxygen atom and we place it between the oxygen atom and its neighbor. Then we will place the 5 electrons left from the previous step into 3 groups. When we place the electrons left from the previous step into groups, we prefer to put them into groups of 2s unless we have an odd number of electrons. If we have odd number of electrons left from the previous step into groups, we will have one group with only 1 electron. All the other groups should have 2 electrons. From the skeleton structure, the chlorine atom in the center has 2 neighbors. Therefore, we need to take 1 valence electron of the chlorine atom for each neighbor. We place one of the valence electrons between the chlorine atom and the oxygen atom on the left. We place another electron between the central chlorine atom and the oxygen atom on the right. Then we will place the 5 electrons left from the previous step into 3 groups. We will do the same for the oxygen atom on the right. Well, you may wonder, Dr. H, where do we place this additional electron? Well, in principle, we will place this electron next to the most electronegative atom of the molecule or ion. In this case, it should be oxygen atom. But we have 2 oxygen atoms. It seems you have to pick which oxygen atom you want to give this electron to. Actually, it does not matter. Let's place this additional electron to the oxygen atom on the right. Every time when you place one additional electron to an atom, you put a -1 formal charge next to the atom. The next step is to replace the shared electrons between the 2 atoms with a stick, which is a single bond in the Lewis structure. Then, what we need to do next is to make sure every atom has an octet or extended octet. Well, now let me explain what is an octet. An octet means an atom must have 8 octet electrons. Octet electrons are the electrons we place next to that atom. It includes lone pair electrons, which are not shared between atoms, and shared pair electrons, which are shared between 2 atoms. The lone pair electrons are only counted as octet electrons for 1 atom. The shared pair electrons are counted as octet electrons for both atoms. Well, let's count the number of octet electrons for the oxygen atom on the right. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7. Well, remember, the goal of the next step is to make sure every atom have an octet or extended octet. The oxygen atom on the right already have an octet. Let's check the chlorine atom in the center. It has more than 8 electrons, but remember, the valence shell of the chlorine atom is n equals 3 shell. Therefore, it can have more than 8 electrons, which we call an extended octet. So, 9 octet electrons is good for chlorine atom. Well, let's check the oxygen atom on the left. It has 7 octet electrons. This is the only atom that is not good. Therefore, we have to increase the number of octet electrons for the oxygen atom on the left. There are 2 ways, and only 2 ways, to increase the number of octet electrons. One way is to share. To share means we will create another shared pair by each atom contribute an electron. To share will increase the number of octet electrons for both atoms by 1. To share does not create any formal charges. The second method to increase the number of octet electrons is to borrow an electron from its direct neighbor. This is called to borrow. To borrow will increase the number of octet electrons for one atom. It will decrease the number of octet electrons for the other atom. It will create 2 formal charges. Therefore, if possible, we want to share electrons than to borrow an electron. We only borrow an electron if to share an electron pair will create a Lewis structure that will violate one of the rules of the Lewis structures. Well, let's try to share first. Well, if we share one additional pair of electrons between the oxygen atom on the left and the central chlorine atom, the number of octet electrons for the oxygen atom on the left will be 1, 2, 3, 4, 5, 6, 7, 8. The number of octet electrons for the central chlorine atom will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, as we can see here, the number of octet electrons for each atom does increase by 1 for each atom. Well, let's replace this shared pair electrons with another stick. Well, when we look at this Lewis structure, every atom has either an octet or extended octet. It does not violate any rule we have. Therefore, this should be a good Lewis structure. When we look at this Lewis structure, it has 1 double bond and 1 single bond. According to the rule, if the Lewis structure has 2 or more bonds, and at least one of the bonds is a double bond or a triple bond, we should try to see if we can find resonance structures for the molecule or ion. Actually, chloride does have 1 more resonance structure, which means chloride has 2 resonance structures. Now let me show you how to get other resonance structures from the structure we just got. In general, all resonance structures should have the same number of bonds and the same number of lone pair electrons. 1, 2, 3, 1, 2, 3. 1, 2, 3, 4, 5, 6, 7 pairs. 1, 2, 3, 4, 5, 6, 7 pairs. The first step is to rearrange the bonds. From the Lewis structure we have, it has 1 double bond, it has 1 single bond. The only other way to rearrange the bonds is we put a double bond here, a single bond here. The next step is to place the lone pair electrons next to each non-central atom to make an octet for every non-central atom. Then we will put all the lone pair electrons next to the central atom. Remember, we're not done yet. We have to calculate the formal charges of every atom in the Lewis structure. The formal charge of an atom is equal to the number of valence electrons minus the number of lone pair electrons minus half of the bonding pair electrons. Let's calculate the formal charge of every atom. Well, from our calculation, The oxygen atom on the left has -1 formal charge. The other two atoms has 0 formal charge. Therefore, we will put a -1 formal charge next to the oxygen atom on the left. You must include all resonance structures with all non-zero formal charges labeled correctly. You also need to include a double arrow between the two resonance structures.